Recently, very important news has emerged about solar power and stellar winds. The first news with us says, space-based solar power may be one step closer to reality thanks to this key test. A first-of-its-kind lab demonstration shows how solar power transmission from space could work. The demonstration, carried out by base startup Space Solar, tested a special beaming device that can wirelessly transmit power 360 degrees around. That would be important for a potential future space-based power station, as its position toward the Sun and Earth would change over the course of each day due to our planet's rotation. The demonstrator is a key component of the Cassiopeia space-based solar power plant concept that is being developed by Space Solar. The company envisions that Cassiopeia could be in space within a decade, providing gigawatts of clean energy much more efficiently than solar plants on Earth. Martin Soltau of Space Solar said in an emailed statement, "We're thrilled to be able to demonstrate the next phase in the development of our technology. Space Solar's successful testing of the 360-degree power beaming technology marks a pivotal moment in our mission to revolutionize space-based solar power." Cassiopeia would be placed in geostationary orbit, a path about 36,000 kilometers above Earth in which the orbital velocity of a satellite matches the speed of Earth's rotation. As a result, a spacecraft at this altitude appears suspended above a fixed region on Earth. While the demonstrator used in the lab experiment was only 0.5 meters wide, Cassiopeia would ultimately be a vast modular structure some 1.7 kilometers across. The plant, consisting of large, lightweight solar panels and a set of mirrors collecting sunlight, would be assembled in orbit by robots and would require 6 to 8 launches of SpaceX's next-gen Starship megarocket to deliver all its components to space. The recently tested component will ensure that the giant satellite has a constant view of both Earth and the Sun in order to provide clean energy 24/7, unlike solar plants on Earth, which only work during daytime and get affected by bad weather. The intermittent nature of terrestrial renewable power generation is a major concern, as other types of energy generation are needed to ensure that lights stay on during unfavorable weather. Currently, electrical grids rely either on nuclear plants or gas and coal-fired power stations as a backup, but both technologies have their problems. Nuclear power plants generate potentially dangerous waste, and gas and coal power stations are a source of greenhouse gas emissions, which the world is trying to eliminate in order to stop the progression of climate change. Paul Bate, the chief executive of the space agency which supports the project, said in a separate statement, "This successful test is a really important milestone on the way to making space-based solar power a reality. Safe, wireless, 360-degree energy transmission is a game changer and demonstrates the leading position in this new energy revolution, quite literally harnessing the power of space to benefit life on Earth." Electrical power generated by Cassiopeia would be converted into high-frequency radio waves, which would be beamed down to Earth, where they would be transformed back into electrical power. The demonstration also tested a precision pointing system that would ensure the waves don't pose any safety risk to humans living around the receiving station. A single Cassiopeia plant could power more than 1 million homes, researchers estimate. Solar power plants in space, although difficult to build, would produce energy 13 times more efficiently compared to those on Earth, as their view of the Sun is not obscured by atmospheric gases.
The last news with us says, these 3 stars are losing weight fast thanks to stellar winds way stronger than the Sun's. Astronomers have, for the first time, detected stellar winds blowing from 3 main sequence stars similar to the Sun. The observation helped determine the rates at which these stars lose mass via their stellar winds, finding these winds shrink about 6 to 7 times as fast as the Sun loses mass via its own solar winds. The team behind the research reached these findings by observing X-rays emitted by a hot plasma bubble called the astrosphere that surrounds star systems. This plasma gets inflated by stellar winds slamming into the interstellar medium, which refers to gas and dust that exists between stars. Astrospheres are analogous to the heliosphere that surrounds the solar system. Stellar winds can also trigger processes that evaporate the atmospheres of planets that orbit the stars from which the winds flow, reducing the capacity for those worlds to host life. The escape rate of planetary atmospheres is slow, but these losses can accumulate, transforming an Earth-like world to a barren, atmosphere-less space rock over the course of millions of years. This means these new observations can help scientists understand how planets evolve around sun-like stars and could aid in identifying which planetary systems are more likely to have habitable planets. Despite the importance of stellar winds to planetary systems evolution, the winds of some main sequence stars have been very difficult to measure. Research leader and University of Vienna astrophysicist Christina Kislyakova said in a statement in the solar system, solar wind charge exchange emission has been observed from planets, comets, and the heliosphere, and provides a natural laboratory to study the solar wind's composition. Observing this emission from distant stars is much more tricky due to the faintness of the signal. Kislyakova added that the distance to these stars makes it very difficult to disentangle X-ray signals emitted by the astrosphere from X-ray emissions of the star itself, which appears spread over the observing telescope's field of view. After making observations of these star systems with the XMM Newton Space Telescope, however, the team developed a new algorithm to disentangle stellar and astroperic contributions to X-ray emissions. This allowed the researchers to detect the exchange of charge between oxygen ions in the stellar winds and neutral atoms in the interstellar medium of three main sequence stars, 70 Alpha located some 16.6 light-years away, Epsilon Eridani, which lies about 10.5 light-years away, and 61 Cygni, a binary star system approximately 11.4 light-years from Earth. This has been the first time X-ray charge exchange emission from astrospheres of such stars has been detected. Our estimated mass loss rates can be used as a benchmark for stellar wind models and expand our limited observational evidence for the winds of sun-like stars. The team determined that 70 Alpha was losing mass at a rate around 67 times that of the Sun, and Epsilon Eridani was losing mass around 16 times as fast as the Sun. 61 Cygni was losing mass to Solis, albeit at a rate that is still 10 times faster than that of our star. Thus, the stellar winds of these stars that blast their planets and inflate their astrospheres are much more powerful than solar winds flowing from the Sun. This may be because these stars have much stronger magnetic activity than our host star. There have been worldwide efforts over 3 decades to substantiate the presence of winds around sun-like stars and measure their strengths, but so far only indirect evidence based on their secondary effects on the star or its environment alluded to the existence of such winds. Our group previously tried to detect radio emission from the winds, but could only place upper limits to the wind strengths while not detecting the winds themselves. New X-ray based results pave the way to finding and even imaging these winds directly and studying their interactions with surrounding planets. Thank you very much for watching. Goodbye.